Okay, one last video, people. Here we go. Graphing linear equations from slope-intercept form. Slope-intercept form is our third and final method we will use for graphing linear equations. So keeping in mind that a linear equation is an equation that models a linear function. Slope-intercept form is an equation in the form y equals mx plus b. M is the slope of the line, b is the y-intercept of the line. Also remember when we talked about x and y intercepts, so this is going to be the point where the line crosses the y-axis. I'm just going to jot that down here too. Point where line crosses y-axis. You know, last video and I'm still not mastering this pen down. Alright, there we go. Alright, so just to review graphing with intercepts, this first one we're going to graph using the x and y intercepts. So if you recall, we write down our x-intercept and our y-intercept columns. And to find the x-intercept, we plug 0 in for y and solve for x. So instead of putting y equals 3/4 x minus 2, I'm going to put 0 equals 3/4 x minus 2. Solve for x, so add 2 to both sides. 2 equals 3/4 x. Now to solve for x here, we're going to multiply both sides by 4/3, which I get 8/3. And that's a decimal, it doesn't terminate, but for our graphing purposes, we're going to say it's about 2.7. So that's our x-intercept, where the line's going to cross the x-axis. Moving over to the y-intercept, we'll take our equation and plug 0 in for x, and then solve for y. And this side's a little easier. We get y equals -2. So moving over to our graph, we're going to go to where x is about 2.7 over 1, 2, a little more than a half. I put a point for my x-intercept. And for my y, I'm going to go back to the origin, go down 2, put my y-intercept. I should have marked 2. This is our y-axis, the x-axis. And taking your ruler, you want to connect your 2 points, extend, and draw arrows. So that was graphing our linear equation using x and y intercepts. Well, we don't have to do that every time, especially when our equation's written in slope-intercept form. Instead, we can use our slope and our y-intercept to graph our line. So keep in mind, we're going to begin at the b value, and we're going to move using m, our slope. So b is our y-intercept, and m is our slope. So let me label, here's our y-axis, here's our x-axis. And I'm also going to label, so if this is in slope-intercept form, right? Y equals mx plus b. That means my slope is 3/4. That's what is in front of the x value. My y-intercept is a -2. So going over to our graph, I'm going to start on the y-axis at -2. So go down 2 and put a point. Now remember from the last lesson that slope is change in y over change in x. So from -2, I'm going to go up 3. 1, 2, 3. And I'm going to move to the right 4. 1, 2, 3, 4. And that is where I'm going to put a point. The reason I went up and to the right is because the slope is positive. After I get my 2 points drawn, I will connect them using the ruler that I don't have, extend my line, and draw arrows. So that's graphing the same line using slope-intercept form. Let's look at another example, graphing in slope-intercept form. Let's first label our x and y axes. And again, this is in slope-intercept form, y equals mx plus b. Now labeling what we know. This time our slope is a -1/2. our y-intercept is a positive 3. So moving over to our graph, again starting on the y-axis, I will go up 3 and put a point. Now to get my next point from 3, so from where y is 3, I'm going to go down 1, right 2. Because the slope's negative, I went down 1, right 2, put a point. Also, another option, remember we said with slope, just one of the numbers has to have the negative for the whole slope to be negative, or the whole fraction. This is the same as 1 over negative 2. So if it ever happens you run out of squares, maybe you can't go down and right, you could always go up 1, left 2. So it's just another option. Remember, you only need 2 points to graph a line. However, I want to give you another option in case you run out of room on the graph. All right, so then taking your ruler, go ahead and connect your points and draw your arrows. So there's the graph of the line y equals negative 1/2 x plus 3 using slope-intercept form. All right, now might be a good time to hit pause and try number 3 on your own. I'll give you a hint. It's in slope-intercept form. Might want to label your axes and identify what your slope and y-intercept are first. Okay, so our slope here is 3. Now we have been saying that slope is change in y over change in x, or rise over run. Well, we want to make that a fraction by putting our 3 over 1. My y-intercept is going to be negative 1. So going over to the graph, our first point will be where y is negative 1, so negative 1 on the y-axis. To get my next point, I will go up 3 and to the right 1. Like the last slide, when the slope was negative, I said if you ran out of squares, you could have gone up and left. Again, let's say your slope's positive, but maybe you run out of squares, you can't go up anymore. You could also go down 3, left 1. Then you want to go ahead and connect those points and draw your arrows. All right, last example. You might notice a little different. It's not in slope-intercept form, right? Y equals mx plus b. This one's pretty easy to get in a slope-intercept form. If I subtract 2x from both sides, so I want to get y by itself, I get y equals negative 2x. And now my equation is in slope-intercept form. So let's identify our slope and our y-intercept. Well, my slope's going to be negative 2. Make that a fraction by putting it over 1. And if you notice, there's nothing after the 2x. So where am I going to start on my graph? Where's my graph going across the y-axis? Well, that will be at 0. So my first point is going to be at 0. From 0, I'm going to go down 2, right 1. Another option would have been from 0 to go up 2 and left 1. All right, go ahead, using your ruler, connect your points, draw your line, put your arrows in, and there you go. We transformed an equation that was not in slope-intercept form into slope-intercept form and graphed. Looks good, people. Any questions? Come see me. Otherwise, good luck graphing your linear equations in slope-intercept form.